Hello. So today we're going to cover section 11.1, which is limits. And here, okay. Oh, that's right, because I shrunk this. There we go. When we're talking about limits, you're talking about how it gets close to the line or a value. And when we look at this function, we know that x cannot equal 2 because that would give us 0 in the denominator. So our domain would be everything except for 2. Bringing the 2 over, x cannot equal 2. So we want to find out what happens as it gets close to 2. And we can look a little bit larger than 2. We could look a little bit smaller than 2. And so that's what we're going to do. First, we're going to look a little bit larger. So to do that, we're going to plug it into our calculator. Now you want to plug the equation in. So you want to hit, I'll turn it on first, hit Y. Now you want to clear anything that's in there. And then the numerator and denominator, if you have a T3, it has to be in parentheses. But if it's a 84, it makes a fraction bar. You don't have to have the parentheses, but mine does. So I put a parenthesis, x squared minus 4, x squared minus 4, close the parenthesis, and then divide by another parenthesis, x minus 2, and close that parenthesis. Now I'm not worried about the window because we're not going to graph it. We're going to go over to the table and plug in values. And so we hit, before we go to the table, see table set, hit second in table set, and make sure that it's on, move this into the light a little better, make sure it's on ask and not auto. This way we can plug values in. If it's on auto, it's going to plug them. So make sure it's on ask. That was under table set up here. Then second and quit. Now we're going to go to table and plug in values, and I'm going to delete the ones that are there just by hitting delete. So I'm going to plug in 2.1, 2.01, 2.001, and 2.1, and then hit enter. 2.01 and hit enter. 2.001 and 2.0001. Notice the closer and closer I get to 2, this value is getting closer and closer to 4. That means the limit as x approaches 2, and this is a little larger, so it's from the right, equals 4. So one way of finding a limit is to plug in values and see what you get close to. As you're getting closer and closer to 2, this gets closer and closer to 4. Well, does that also happen from the other side with the smaller values? We'll go back and enter 1.9, 1.99, 1.999, and see what the values are approaching. So if I go back up and I click 1.9, 1.99, 1.999. Oops. There we go. We're still, notice, getting closer and closer to 4. So this is also getting closer and closer to 4 as this gets closer and closer to 2. That means the limit as x approaches 2 from the left, because it's smaller, for the function equals 4. So this minus up here means from the left. So it's a little bit smaller than 2, because we can't just plug 2 in, we get 0 in the denominator. So that's one way of looking at a limit. Now, another theorem, I guess, if the limit of a function as x approaches a value from the right equals the limit as x approaches the same value from the left, they both equal the same value, we'll say L, then the limit as x approaches A is L. So from the right and the left are the same, even if f of A does not exist, we can find the limit at that value. Now, if these are not equal, if the limit as x approaches A from the right does not equal the limit as x approaches A from the left, then the limit as x approaches A does not exist. And you could use D and E for that. Okay, looking at some graphs. Let's look at number 7, I think. Yeah, 7 and 8. So in number 7, okay. Okay. So number 7, I'm going to focus it a little better for you. Oh, that's much better. Just want to make sure it's recording. Okay, because well, just a double check. I don't know why something sounded like it might not be recording. Okay, when we're looking at these limits, we want to find the limit as x approaches 0 of the function. Well, x0 would be here. And notice from the right and from the left, they're both approaching 0. So that means that the function exists and it's 0. Even though at f of 0, it's up here at 2, the limit from the right and the left are 0. If we look at 2, this one says the limit as x approaches 2. Well, notice they're coming in at 2 different spots. If we look at the limit as x approaches 2 from the right would be a little larger, so we're talking here. It's approaching 1. This one would be on the left, so it would be the limit as approaches 2 from the left. You can even think of a dotted line coming down here. This is on the right, this is on the left. So from the left, our y value is a -2. on the right, we're approaching, these are y values. We're approaching 1, and on this one, -2. Because these two are not equal, this one does not exist. This one, when we look from the right and from the left, it's the same. It's approaching 0. That's why this one's 0. Also notice how they're coming in together. Then it exists. When they're separated, they're coming at 2 different values. It doesn't exist. Okay, let's look at number 8. The first one is 3. Notice that 3 from the right, this would be the right, from the right and from the left. You could think of a line going through the right side of the line, left side of the line. They are both going to 2. So the limit from the right, the limit from the left are both 2, which means this limit is also 2. Because they're all coming in at the same value. Whereas 5, this one here, notice they're coming in at different values. So this is not going to exist. Let's find limit from the right and the left for practice. Approaches 5 from the right, and then 5 from the left. If we're on the right side, our line's up here, and it's approaching 3. If we go to the left, our line is down here, and it's approaching -2. Notice these two are not equal, so this one does not exist. Let's look at another one. Number 11. This is kind of like that sales function graph in the last chapter. Notice it's growing and then it tapers off, and it's approaching this value. So it's saying the limit as x approaches infinity. Oops, I'm covering it up a little. There we go. That means it's going towards a value, and as x is getting positively large, this is going this way, it will not cross that asymptote. So it's approaching 3. It's getting close to this value. This one, notice negative infinity, it would be going this way because x would be negatively large. And that arrow means it keeps going. It's getting large. So what they say is the limit does not exist, but then they also asked if it's approaching positive or negative infinity. In this case, it's a positive infinity. So when a limit doesn't exist and it's positive or negative infinity, they will ask for that. So it doesn't exist because it's approaching infinity. And it's positive because it's going up. We don't always have a graph. When we don't have a graph, there's a few steps. First one, so when we're looking for limits, the first step you want to do, just plug it in. So we plug x. If you get an answer, then that's the limit. Let's try one. So if we have the limit as x approaches 2 of x squared plus 3. Plug in 2, see what you get. 2 squared is 4, plus 3, 7. So our limit's 7. Limit as x approaches 2, x squared minus 4 over x plus 2. If we plug that in, 2 squared minus 4 over 2 plus 2 is 0 over 4, or which is fine. We just can't have 0 in the denominator. So when you plug it in, if you get a value, you're done. Of course, nothing's that easy. If we plug in for x, and you get 0 over 0, you need to simplify. So you simplify the fraction. What was the one we started with? X squared minus 4 and x minus 2. So the limit as x approaches 2 of x squared minus 4 over x minus 2. And what happens when we plug the 2 in? We get 2 squared minus 4 over 2 minus 2. We get 0 over 0. That's indeterminate, which means you need to go back, reduce, and plug it in again. So we reduce this. Notice the top will factor. X minus 2 and x plus 2 all over x minus 2. We know that there'll be a common factor because that's why we got 0 over 0. So those cancel and leave the limit as x approaches 2 of x plus 2. Now plug it in. 2 plus 2 equals 4. So the limit as x approaches 2 is 4. Which is what we got here. The limit from the left and the limit from the right were both 4, which means the limit at 2 was 4. That's another way of getting it. So besides looking at the graph or plugging in values, you can simplify your function. Let's try. Limit as x approaches 5, x squared minus 3x minus 10 over x minus 5. So first thing we do is plug in 5. And when we plug in 5, we get 0 over 0. So we need to factor. Now, if factoring is not your strong suit, because you got 0 over 0, we know x minus 5 is one of the factors. So use that to help you. Well, this is x squared, so x times x has to be x squared. And if this is a negative 5, and we need a negative 10, this needs to be a positive 2. So you can work backwards and let it help you factor it. Notice that the x minus 5s cancel. And then we take the limit as x approaches 5. And now we only have x plus 2. Plug in the 5. 5 plus 2 equals 7. So we get 7 for our answer. I was looking for which, I want to make sure I covered all the ones I wanted. 30. Fractions. Okay. Now these are from your book. If you do look on your ebook, they're at the end of section 11.1. But if we find the limit as x approaches 0 of 1 over x plus 2 plus 1 over 2 all over x. And we're finding 0. If we plug in 0 here, I think I got a, oh, this is a -1. Okay. If we plug in 0 here, we'll have -1/2 plus a half, which is 0, over 0. So that means this needs to be simplified. Now, when you have a fraction within a fraction, you can multiply by the denominators. We could take each term and multiply by 2 times x plus 2. Don't multiply the denominator out. So when we multiply here, the x plus 2's cancel, and we're left with a -2. Let me go downward. So these cancel and leave -2. The 2's cancel and leave plus x plus 2 all over x times 2 times x plus 2. Then the 2's cancel, and we're left the limit as x approaches 0 of x over x times 2 times x plus 2. Notice then the x's cancel. Leave the limit as x approaches 0 of, when this cancels, it leaves the 1 that's in front of it, over 2 times x plus 2. Now that it's simplified, we can plug our 0 in again. And we have 1 over 2 times 0 plus 2, or 1/4. So some of them will have a lot of simplifying that you need to do. Another different one is the square root. If we have the limit as x approaches 36, we have the square root of x minus 6 over x minus 36. Now, notice when with 36, we get 6 minus 6, which is 0. And 36 minus 36 is 0. So we have to do something. There's two different things you could do. One is to multiply by the conjugate, or the second one is if you notice this factor is perfect square. I think it's easier to multiply by the conjugate. But I could show you the factor. When this is x to the first, so on top we have the square root of x minus 6. When this is x to the first, this will factor into square root of x minus 6 and the square root of x plus 6. Now, if you multiply that out, you will see that it gives you x minus 36. Because square root of x times the square root of x is x. And a positive 6x and a negative 6 square root of x, they cancel. And then negative 6 and times 6 is negative 36. And then these cancel and leave the limit as x approaches 36 of 1 over the square root of x plus 6. Plug in your 36, and we get 1/12. Okay. One last one on these. There's one other possibility. The third one. The third possibility is when you plug in for x, you get a number over 0. If you get a number over 0, the limit does not exist. If it doesn't exist, then it's approaching positive or negative infinity. And one way to see what it's doing is to look at the graph. If we look at the limit as x approaches a -1, the x plus 5 over x plus 1, and we plug in our values. -1 plus 5 over -1 plus 1 gives us 4 over 0. So the limit doesn't exist. One way of looking at it is to look at the graph. Now, if we look at the graph, we want to plug it in. Let's put a window in, though. Let me graph it. -10, 10, -10, 10. So under y equals, make sure you put parentheses, x plus 5. So you're just plugging this in. Divided by x plus 1. And I use the window -10, 10, -10, 10. And y equals. So then we hit graph, and we get this. Now notice we're approaching -1, which is here. This is the asymptote. And when we're approaching -1 from the right, it's going to infinity. So the limit as x approaches -1 from the right, that would be on this side, is positive infinity. The limit as x approaches -1 from the left is negative infinity. Because we're approaching over here, it's going down, and that's negative infinity. So it would be negative infinity. We also have limits to infinity, but we will look at those in a second section. Thank you.